Hello everyone, this is Big Time Math. It's your algebra review test number 1. So folks, this is a review for the very first test. You're not doing it in class, so you have the opportunity. You could have come to Big Time Math this past Wednesday, or you can watch this video and follow along. And if you do well on this review, and you study it and you watch this video, folks, guess what? You're going to do awesome on that very first test coming up this Friday. So, first thing we're going to do is finding slope / the rate of change. So how do you find the slope or rate of change? From a graph. Most likely you're going to find 2 points, and you're going to count those points and do a rise over run. You can rise up, go down, or always run to the right. So how do you find the rate of change or slope from a table or 2 points? You're going to be using this formula right here. So y2 minus y1, x2 minus x1, or by just taking the change in y over the change of x. And the change of y is subtraction, the change of x is subtraction. Remember, the y's are always on top because you're rising up, and run is always on the bottom with the x's because you're going to the right. Next thing we have here is actually finding some rates of change. So let's look and see if we can find the rate of change on these mugs. First thing I need 2 points if I'm looking at the graph, because I'm looking at rise over run. Most likely the best thing I always do is try to find the y-intercept. Now that I have the y-intercept, I need to find another point. Nope. Bam! There's that point right there. So how do I get from one point to the other? Well, first you got to rise up. And how far am I going to rise up? 1, 2, 3. So I know I'm going up 3 and going over 1, 2, and went over 2. So that is my slope, which is my m, so up 3 over 2. If you notice, this is a positive slope, and that is a positive graph. The graph is going up to the right, and therefore up 3 over 2. And if you just want to check it, you could go 1, 2, 3 over 1, 2, bam! It lands right on the graph. So that's pretty big baller shot caller. So my slope for the graph is 3 over 2. Remember, it's how many you go up or down, and then always to the right. Uh-oh, now we've got a table. For this table, we've got several different points, so we can do change of y over change of x. So I'm just going to pick out 2 easy points, and most people start here to here and here to here. So what you do is you grab your trusty calculator. Bam! There's my calculator right here. And so turn that mug on. All right. Now, what I'm going to do here is look for, let's see, change in the y. So if I call this y2 and that's y1, this could be x2, x1. On top, if you do your little formula, it's always y2 minus y1 over x2 minus x1. So in this case, I'm going to do negative 8.2 minus, now be careful here because it's minus a negative 10.6. Don't make that minus your negative. It has to go separately. On the bottom, it's negative 4 minus negative 7. So, if I have trouble doing this, all I'm going to do is say, man, I got this calculator, you know what I'm saying? So I'm just going to type this mug in. So I've got negative 8.2 minus, then a negative 10.6. Press enter, 2.4. So on top, I get a 2.4. On the bottom, same thing, just use your trusty calculator. And I've got negative 4 minus negative 7. When I press enter, I get a positive 3. So I'm going to put positive 3 on the bottom there. Whoa, don't mean to move that. Let's do 3 here. But I don't like decimals and whole numbers, so I'm going to use my trusty calculator. And I'm just going to put 2.4 divided by 3. But if I press enter, I'm going to get a weird decimal. So I'm just going to go over here and press the math button and then enter. And it's going to reduce that to the best fraction possible. So in this case, my fraction is what? 4 over 5. So my rate of change is 4 over 5. And it's a positive 4 over 5 going up 4 over 5. All right. Now I've got the point right here. Same deal. If you want to do x1, y1, x2, y2, you definitely could. And I always like to rewrite the formula, y1 minus y2, x2 minus x1. And then just plug it in, plug it in. Guys, this is so easy. Just negative 10 minus 8 over 2 minus 8. Just plug it in, man. It's not that hard. And then when you got negative 10 minus 8, you can use the calculator. But if you're a big baller shot caller and you've got this, negative 10, and then I'm going back 8 more, would be negative 18. 2 minus 8 is a negative 6. Then we have to simplify this mug. So 2 negatives make a positive. 18 divided by 6 is 3. Therefore, and you can leave it a fraction if you want, 3 over 1. It doesn't matter, which is going to give my m. So m is 3, or if you want to say 3 over 1 for that rise over run demonstration. All right, so there's your rate of change, folks. Great job there. Let's move on down. Now, it says here, the graph shows the altitude of a truck as a driver descends a hill. So he's driving downhill. Identify the following what represents or means by reading the answer choices below. So let's see what we got up in this mug. X-intercept. Well, X-intercept means I'm going to the, voila, X-axis, and I go, bam! There it is. It just so happens that that X-intercept is going to be an ordered pair. Let's draw that a little bit better. Ordered pair. And since I'm looking for an X, I've got to have an X value. In this case, it's 6. And if it's an X-intercept, the Y value is always 0. Okay? Next question says, what does this represent or mean? Well, if I know X's is the hours and Y-axis is the amount of feet, well, let's check it out. I have 6 hours, 0 feet. The graph is going down, right? It's going negative. So, I would say in 6 hours, what's our altitude in feet? We're at 0 feet altitude, if you want to write that all out. Okay, so after 6 hours, we're at 0 feet. So in 6 hours, we hit the ground, okay? The truck driver descended the hill all the way to the bottom. So in 6 hours, 0 altitude feet. And if you just want to say, you can use that answer if you like. Or if you want to say it took 6 hours to get down the hill. To get down the hill. All right, so 6 hours to get down the hill. Does that make sense? The altitude all the way down to 0. Bam! 6, 0. The y-intercept, let's check that mug out. The y-intercept has to cross the y-axis. Bam! There it is. So we know that's the number. And since it's a y-intercept, I have to have a y value, and in this case it's 1500. And if we're finding the y-intercept, the x is always 0. You starting to see a pattern? X-intercept, y is 0, y-intercept, x is 0. All right, so what does that represent? Well, it just so happens that's where we are starting. That's the initial point. So we could say we started at 1,500 feet. All right, so our starting point, our initial value is starting at 1,500. Starting and y-intercept always go together. That's usually where we're going to start on a graph, is the y-intercept. Now we're trying to find slope. Now slope, we're pretty good at this, especially with a graph, and we already did that up top, is rise over run. But in this case, the graph is going down, and you always start on the left. So let's switch colors here to red. So here's my graph here, and I already see 2 points. I could go in there and find other points, but nothing's going to be as perfect as this point and this point. So I personally, well, here's 1,500 and here's 0. So I'm going down 1,500. That's my y value. So I'm going down 1,500 and going across 6 over 6. So my rise over run went down 1,500 over 6. But again, I don't like that number because that's a huge number. And so probably not going to see that answer on any test. So I go to my calculator and I say, hey, yo, can you help me reduce this mug? He's like, for shizzle my nizzle bizzle. So all I do is I turn this mug on. I'm going to clear out everything else. I see negative 1,500 divided by 6 and then reducing is math, enter, enter. So math, enter, enter. And it comes out to negative 250. So what that means is negative 250, or if you like to keep it in fraction, negative 250 over 1. Okay? And what does that represent, or what does that mean? So y is on top, and y is feet. X is on the bottom, and x is hours. So I'm looking at these two things right here. And if I want to put that in word, since it's negative, we're going down 250 feet per, and it's 1, and we're talking about hours, so per hour. So my slope is down 250 feet per hour. Okay, so we're losing 250 feet in altitude per hour. Next answer choices are the initial height that the driver started on the hill. Well, the initial, I like to say that's where did I start? So we already said we started at 1,500. So 1,500 feet. That's the initial value there. The rate of train, or the rate at which the driver descends down the hill, we already know, going 250 per hour. If you want to say per hour, you can. And the number of hours that the driver took to go down the hill and reach the ground. So he's going downhill. Bam! How many hours is that? We already said 6 hours. So you can get a lot of information right from this graph. All right, that's page 1, folks. 3 more pages. Let's go ahead and hit them up. So, whoop. We're going to go through these fairly quickly. Undefined slope. Undefined slope, we already know, is some type of x equals graph. And if it's undefined, that means you have no slope. So let's just draw this. If it's x equals, it means it's got to touch the x-axis. So that's x equals 5. That's undefined. X equals 2. That's undefined. X equals negative 3. That's undefined. You're starting to see the pattern. X equals negative 6. That's undefined. All of those graphs are undefined slopes. Okay? Now, if we're going to go zero slope, that means there's zero elevation. That means it's flat. So y equals 1. That's zero slope. Y equals 4. That's zero slope. Y equals negative 4. Zero slope. Y equals negative 6. Zero slope. So zero slope is always flat. Undefined slope is always vertical. So we got undefined slope, which is always vertical, and zero slope is always horizontal. And something that kind of helps me, I know it's zero slope because it's horizontal. They both have the letter Z. Okay? Both have the letter Z, if that helps. Horizontal, 0. So, bam! That's pretty simple there. All right, going down to the next spot, it's the little cross out. All the words that are not associated with the graph below. Now, we got to be careful here because it does give us a standard form, and that may come into play in just a bit. So let's see. X-intercept is 0, negative 1. Man, hold up. It says X-intercept, but it gave me a Y value. I don't even have to look at the graph. That is wrong. So peace out. Let me just, how about we do a highlighter? Okay. That is, burp. Let's make the highlighter look. That is wrong. You cannot do that, yo. This says it's not a function. Not a function, but if I do my vertical line test, 1, 1, 1, 1, 1. Anytime I do a vertical line test, it only touches once, so it is a function. So I'm going to back that bug up and go ahead and highlight this. That's wrong. Does it have a positive slope? Is the graph going up to the right? Now remember, you always start on the left and you go to the right, just like you read a book. You always go left to right. Is it going up? It is, so that is definitely positive slope. So that is ding, 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 ding. That's good to go. Let's see what else we got up in here. Negative slope. Well, it can't have positive and negative slope, so in this case, we know that's wrong. And since we already said it is not a function, it has to be a function, so we know that's right. Check. Okay. A couple of more. Y-intercept. It says right here that the y-intercept is at 0. Y-intercept has a y value, so that's good. But let's go check it on the graph. If I go right here, bam, That is perfect. So that is a check. So we're going to go ahead and give this bad boy a check. That's good to go. Now we've got two that are going to be kind of tricky. Tricky. Look at the slope right here. It says go up 4 and to the right 3. Well, we already made 1 point. Can I go up 1, 2, 3, 4 over 3? 1, 2, 3. What? There's nothing there. It does not touch the graph. Therefore, this cannot be the slope. But since we're on it, let's go ahead and try to figure out the slope here. So I'm going to grab my trusty eraser. Come over here and erase this. Let's figure out what the slope is just for fun. I'm going to go, here's 1, 2, 3, 1, 2, 3, 4. So I know my slope has to be 4. Oh, I almost put the wrong answer again. It's got to be 3 over 4, yo. So we know it's not this. Now, if I can find the slope going up, I can also find the slope going down. So go down 1, 2, 3. So 1, 2, 3 over 1, 2, 3, 4. And there are my points. So up 1, 2, 3, 1, 2, 3, 4. So up 3 over 4, up 3 over 4, up 3 over 4. So the slope is definitely 3/4. But that's where it gets a little tricky with this one right here. Is there a 0 at x equals -1? Now to the eye, it looks like it is, but look at this. Here's 0 or -1, 0. It actually does not touch the graph. And if it did, then our slope would have to be up 1 over 1, but it's not. We just showed that the slope is actually up 3 over 4. So this is definitely not true. Okay? Plus, if that's a 0, and I plug in 0 right here, 4 times 0, then that means that cancels out. You divide by -3, divide by -3. So the actual 0 is at -4/3 or -1.3. So the only 3 that actually work for this graph, it is a positive slope, check. It is a function, check. It does have a y-intercept at 0, 1, check. Okay? Moving on like Donkey Kong. All right. Alina jumped off a cliff into the ocean. That sounds like a lot of fun, folks. In Acapulco while vacationing with some friends. Her height as a function of time could be modeled by the function h of t equals -16t squared plus 16t plus 32, where t is the time in seconds and h is in height in feet. Use the graph to answer the following questions about the quadratic equation represents Elena's jump into the ocean. So, it says give the y-intercept. Well, y-axis is always here. So here's the y-axis. Now, it looks like it's going up by 5s, but if you look really closely, the lines are actually by 1. So 1, 2, so we know that's 32. Plus, if you look right here, 32. That number is always a y-intercept at the end. So, y-intercept means I have to have a y, and x is always 0. X-intercept, if we go down here, here's the x-axis. We go right here. This is where you got to be careful, because some people would say 1, 2, 3, 4. But that's actually not correct, because this is going by 0.5s. 0.5, 1, 1.5. This would actually be 2. Since it's an x-intercept, I need an x value, and the y is 0. Given the vertex. Now remember, the vertex is either going to be a max or a min. They're actually learning that in Algebra 2. We got to figure out which one. Since it's the top of the graph, which would be right here, that is a maximum. So what's that maximum point? Well, we're going to do we need an ordered pair, and it even tells you put the x first. So we're going to go over, boom, boom. That's 0.5. And then we go up, bam! Well, that's right here. There's 35, and it's the line right above 35. So we're looking at 36. And we already just figured out that that's a max because it's at the top of the graph. So we know that is a max. All right. Make sure you know that the vertex and max or min are the same. That's definitely a max. This is the x-intercept. All right, because it's on the x-axis, folks. And this is the y-intercept. All right. You guys are super smart. Y'all could figure that out. You're big baller shot callers. All right, moving on. Now it says in this problem that we just did, Describe what can be determined by the y-intercept. So if we go back here, we're going to go down. The y-intercept was 0.32, and it looks like we're talking about feet and seconds, right? So 0.32. So I'm just going to write that down, 0.32. What can be determined by the y-intercept? Well, we know the, you could say, initial value. We could say the starting point. All right. And we know that we're starting at 32 feet because it's 0 seconds. So starting point would be 32 feet. All right. Describe what can be determined by the x-intercept. Well, we already said the x-intercept was what? 2, 0. So, and the graph was going down, which means she hit the water when? Or she hit the ocean. She hit the ocean in 2 seconds. Wow, man, she was flying down. She jumped, bam, hit the water in 2 seconds. Because time versus feet, right? So she was no longer 32 feet high. She just hit the water. Now the vertex, remember the graph was going bloop, bloop. It looks like she jumped. So the vertex was the maximum height she reached. And what do we say? 36 feet. So man, she jumped up 4 feet in the air because she started at 32, then she hit 36. So that's the maximum height she reached was the vertex. Vertex. So that was pretty simple. All right. What do we got here? 3 graphs. Let's look at these. First one says solutions. Remember solutions are always the x-intercepts. X-intercepts. Intercepts. There we go. So here's one here. What's that point? 0, 0. And here's one here. It looks like 2, 0. So 0, 0, and 2, 0 are my solutions. My y-intercept happens where it crossed the y-axis. Bam! Looks like we do have an x-intercept and a y-intercept that are exact same. That's perfectly fine, but only time that ever happens if it goes to the origin. Now, vertex. This case, vertex is always in the middle. And this, remember, is a max because it's the maximum height. So you just do an ordered pair. You go over 1, up 2. So the ordered pair is 1, 2. And the axis of symmetry, folks, is so simple because if you can find the vertex, you can find the axis of symmetry. It's always x equals, and you steal the vertex, x. It's telling you, hey, yo, I'm right here because the axis of symmetry always goes right through the vertex. Therefore, the axis of symmetry and vertex always share the x. It's that way every single time. And I'll prove it to you as we go down through the next problems. Let's see, this next one says, what are the roots? Well, roots are also x-intercepts. But look here, it never touches the x-axis. So how many roots are there? There are none. Okay, sometimes it doesn't touch the x-axis, which is perfectly okay. Does it touch the y-axis? Bam! It does. And since it's a y-intercept, I need a y value, 3. X is 0. Now, if we're looking at the vertex here, it's right here. It's always the point in the middle. And I like to just tell myself, hey, man, that's a minimum because it's the lowest point. And in this case, go over 1, up 2. Same vertex here as the last one. It's just a different graph. And do you remember about the axis of symmetry? It's always x equals. And you always steal the x value. Caught me there. The x value of the vertex. So in this case, it's just x equals 1. The vertex always tells you the axis of symmetry. And you just go straight through. Bam! And it's x equals, so it's definitely a vertical line. And the last one, again, zeros means x-intercepts. Are you starting to learn something here? X-intercepts has different meanings. Zeros, roots, and solutions. So, yo, if I'm looking right here, this one, holy moly, only touches once. And so that is an x-intercept. So I have to have an x value, which is 1, and the y value is 0. All right. So that's pretty simple there. Then we look at the y-intercept. Where does it touch the y-axis? It's right here. Oh, so cute. Since it's a y-intercept, we're going to go 0 for the x, and in this case, it's 1 for the y. Now, if we're looking at the vertex, remember the vertex is the middle point, and it just so happens that it's the same as the x-intercept here. And again, that is a minimum. So that point happens to be 1, 0. And axis of symmetry, without even drawing a line. I don't even have to draw the line because I always steal the vertex as x. X equals 1. But of course, it goes right through the vertex where the x is 1. Holy moly. All right. Very, very easy there, folks. Sometimes there's no x-intercepts. Sometimes there's one x-intercept. Sometimes there's two x-intercepts. Those are your three options when it comes to quadratic graphs. A couple more left on this page. It says determine if these are a function, or determine whether each relation is a function. So this is pretty simple. And if you remember, in order to be a function, you can only have one x for every y. So let's look at this too. One arrow, that's good, check. One arrow, that's good, check. One arrow, that's good, check. Uh-oh, this says there's two negative ones. So it's like saying this, it's like saying, well, I have a negative 1, 4, and I have a negative 1, 5. But what did we say back in the day? You cannot repeat the x's. So this is definitely not a function. You can't have two arrows coming out of the x's, If that looks funky, then you definitely know it's not a function. When given a graph, we did this in the scavenger hunt, pretty simple. Just do the vertical line test once. Waka, waka, waka. It only touches once each time, folks, so guess what? That's good news. It is a function. Looking at the ordered pairs, let's see how this does. Remember, we really only care about the x's. And look at this. -3, -3. Womp, womp. Automatically, peace out, That cannot happen. Therefore, it's not a function. Make sure you're reading your test carefully, folks, because it may say which one's not a function, or it may say which one is a function. So, be very, very careful when you're reading the test. And right here it says x equals 4. This one's kind of confusing because it says every single x is 4. So if I have an ordered pair, I could do 4, 5. I could do 4, 6. I could do 4, 100. It doesn't matter what ordered pairs I pick. All the x's are 4. And since this x is 4 and this x is 4, I can stop right there because can x's repeat? No. Therefore, that's bad news. And if it's bad news, that means it's not a function. This is telling you, hey, every single x is 4, so it's just telling you, hey, I'm repeating. And if you know your graphs, you got your graph here, you go over 1, 2, 3, 4, it's a vertical line at 4, which we already know is definitely not a function, okay? If it repeats, bad news. Got it? Good. Checking out the last page, folks. We're almost done here. Let's see what we got here. Identify the attributes for the exponential graph. So we've done linear graphs, we've done quadratic graphs, and now we're down to exponentials. But they're all about the same. It's pretty simple stuff to read. So look at this graph. If you're reading it, remember we read a book left to right, and it just so happens this graph started up high and went down low, so that is a decay. It's going down. What was the starting amount of caffeine in the body? So starting amount to me, when I think starting amount, I'm thinking y-intercept. Always y-intercept. So I'm going to sneak over to the graph and go to the y-axis. There it is. And I'm looking for the y-intercept. And bam! Right here. To me, that looks like it's starting right at 160. So I can put 0, 160. Or I could say it started with 160 milligrams. Okay, so that is your starting amount. This is known as the, I already said that, the y-intercept. So I gave you your answer. Y-intercept, or if you want to practice saying this word, initial value. Initial value, starting point, y-intercept. They all mean the same thing, And OMG, I already found the y-intercept for you, which was 0, 160. I was moving ahead. I get so excited about this. And equation of the asymptotes. Now the asymptote, I think right now we're only focused on horizontal asymptote. Horizontal asymptote goes left to right. And it's the line that the graph is approaching. So I can't do a horizontal asymptote here because a line touches it. I need to find a spot on the graph that it's approaching. And it looks to me that it's approaching this line here. So I'm going across. It's going to eventually try to get to this dotted line. So I have to come over here and I have to look, what is the y-intercept of my asymptote? And it just so happens to be 0. Asymptotes are always y equals. And where does it cross the y-axis? At 0. Remember, folks, I'm not looking at the y-intercept. I'm looking at my asymptote where its y-intercept would be. And that, in this case, is 0. So y equals 0. Okay, moving down. Almost done here. Let's see. Based on the information from the graph above, label the following true or false. It says the body lost about 1/2 of its caffeine every 4 years. Now it says about, so if we wanted to say, let's see, we start at 160 and in 4 years we're at, what is that, 100. It's kind of getting close to half. And if you want to make a table, you could say after 0 years 160. Yeah, we can do x and y axis. We can also say at 4 we had 100. At 8 it's getting close to, what is that, 60. And so 60 is almost half of 100. 100 is getting close to 160, but you know, it's kind of a tricky question here, but I want to say true, about 1/2, getting close to that. It also says the body lost about 1/4 of the caffeine every year. Well, if our scale's going by 2 and 1/4 of the caffeine every year, so 1 right here, so it looks like it went down, what is that, 20, then it went down, is 20 1/4 of 160? No, 20 is definitely a lot smaller, so we're just going to go false there. The body lost more of the caffeine between the years 16 and 18 than between years 2 and 4. So, did the body lose more caffeine between 16 and 18 than 2 and 4? Well, let's check it out. Here's 16. Here's 18. And look, it looks like it's maybe close to 25, and then maybe 18, close to 18. So maybe I lost 7. But if I go to years 2 and 4, here's 2. Okay, there's 2, here's 4. Oh, was I supposed to do 16, 18? I'm so sorry, folks. Let's go to 16 and 18 right here. So if I do 25 and 20, I'm actually losing about 5 only. Okay, so still close to 20, 18. So I should have went right here, bam, bam, bam. But let's look between 16, or 2 and 4. So 2 and 4. So here's 2. Here's 4. If I go up to 2, I'm looking probably close to 125. And if I go to 4, we're looking at 100. So this is about 125. So I'm actually losing 25. Holy smokes. So I'm actually losing a lot more between 2 and 4. So did the body lose more between 16 and 18? They lost 5. No. It's actually more right here between 2 and 4. So this is false. Then the body lost less between 16 and 18 than between 2 and 4. Well, we just proved that that's definitely true. It lost less right here, 5, than it did between 2 and 4. Okay. Moving on. We're almost done here. Holy smokes. Getting very, very close. Domain is always what values? X values. Range are always what values? The Y values. And I think we've had teachers do this, X, Y. It's always a domain and range, always the independent and dependent. So if you like Dr. XY, that can go there. So let's look at this table here. It says the domain. Domain, I always like to put X right beside it, so I'm only looking at the X values. And we're going to put these in numerical order. How about -6, -3, 6, 7, and 9.02? Then the range, if we want to change colors there, range is always a y. It's always the y value. And we could say -8, how about 4, 6, 7.02, and 8. Okay, so there's our domain and range. And if I'm looking at the graph right here, again, these are discrete graphs because we're counting the numbers. They're just simply putting in specific values. So domain is also the x value. So I'm only going to look at the x-axis. So here I see there's a 1, there's a 2, there's a 3, 4, 5, and 6. So there are my x values for the domain. And then if I'm looking for my range, range is the, let's do pink. Range is all my y values. So I'm only looking at the y-axis. So now I'm going here, -1, 0, because there's this point right here, 1, 2, 3, and 5. So there are my range values, folks. Remember, range is bottom to top. Started from the bottom, now we're here. Oh, yeah. Range is bottom to top, so don't trip on that. And domain is always left to right, and range is bottom to top. Okay, last problems we have is function notation. Function notation, remember, is f of x equals this equation. Find the following values. So here's x, and it's even telling you the x is -6. So you just simply plug that in. 3/4 times -6 squared minus 2 times -6 plus 6 equals what? Well, it just so happens we have a trusty calculator. So I'm going to bring this calculator over here. Guys, don't be afraid to use your calculator because your calculator will do the hard math for you. Well, if you consider it hard math. So let's see, I'm just going to put 3 divided by 4, parenthesis, -6, close parenthesis, square it, minus 2, parenthesis, -6, close parenthesis, plus 6. I check to make sure I put that in right. Make sure your negatives and your minuses are different. Negative is always just chilling by itself. The minus is being taken away from something. Just simply press enter, and bam! My answer is 45. So if you got 45, that is awesome. Let's try the next one. It says f of 10. So I'm going to put 3/4 times 10 squared minus 2 times 10 plus 6. And since we have a calculator, we're not afraid to use it. I'm just going to, well, there's a couple of different ways here. You could put second graph or second enter and pull it all up, but we're just going to retype it. 3 divided by 4 times 10. We're going to square that mug, minus 2 times 10. Close that mug, plus 6. Make sure I put it in correctly and press enter. And I get 61. All right. All right, folks, there was a lot of questions, man, and I know a lot of stuff we just did there, but if you can do all of that, your test is going to be super duper easy, and you're going to rock it. So good luck on your test, folks. This is Big Time Math, and we'll see you next time.